This video from GMATMathPro.com is the second part of a video we did on data sufficiency hints and tactics. In this video, I'll work through some actual examples of GMAT data sufficiency questions and show you how the tactics and hints that we discussed in the first video can be applied. Okay, so the first one we're going to look at is number 37, and it comes from the official guide to the GMAT, the 12th edition. And it says that the selling price of an article is equal to the cost of the article plus the markup. The markup on a certain television set is what percent of the selling price. So this is a good example of tactic number 3, where we're going to simplify everything we can to something equivalent but easier to work with. So if we look at the first sentence, which is the given information, we can summarize that by saying S is equal to C plus M. So here S is the selling price, and it's equal to the cost, C, plus the markup, M. So that's an equivalent version of that information, but it's easier to deal with. And then the question part of it, the markup on a certain television set, is what percent of the selling price. If we want to know what percentage of the selling price is the markup, we would do M over S times 100%. We'll put a question mark after that to indicate that that is essentially what we're looking for. Now, of course, we don't have to actually calculate that, but we just have to be sure that we're able to calculate it definitively. So let's take a look at the first statement, which says that the markup on the television set is 25% of the cost. So we can summarize that by saying the markup, M, is equal to 0.25, 25% of the cost. So if you look at the given information again, we know S equals C plus M, and what we're trying to find is M over S. So we're trying to find M over S, which means we probably want to get rid of the C in here, and we can do that by multiplying both sides of this top equation by 4. And if we do that, we're going to get 4M is equal to C. And then if we plug C into here, we'll get S equals 4M plus M, or S equals 5M. And again, now we're trying to find out what M over S is. Now, hopefully you can see that this is going to be enough information. If you want to do it a step further, like we know we want to find M over S, and if S equals 5M, we can make a substitution there, replacing S with 5M, then these cancel out and we just get 1/5. But you don't really have to go that far as long as you see that that is enough information. So 1 is enough. So now let's take a look at statement 2. Statement 2 says that the selling price is $250. And of course we still know that S equals C plus M from the given information. But we're ignoring statement 1 for now. So if S equals 250, we can go ahead and plug that in here. So 250 is equal to C plus M. And again, we're trying to find out what is M over S. Okay, now it looks like there's not enough information, but to be sure, we can apply tactic 1, which says to be sure there's not enough information, find 2 different answers that fit the given information. So it's pretty easy to do in this case. We could say maybe the cost is $240 and the markup is 10, or maybe the cost is $200 and the markup is 50. There's nothing in the given information that rules out either of these cases, but in the first case the percentage is much lower than the second case. So that means there's 2 different answers that fit the given, which means statement 2 is not enough information to solve the problem on its own. So that must mean the correct answer is A. Statement 1 is enough, but statement 2 is not. So the next question we'll look at is number 45 from the official guide to the GMAT, which says that if r is a constant and a sub n equals r times n for all positive integers n, for how many values of n is a sub n less than 100? Okay, so there's not much we can really simplify here. We'll just write down the crucial given information here. A sub n equals r times n, where r is a constant. And we'll go ahead and look at statement number 1, which says that a sub 50 is equal to 500. Now if you compare this statement with the statement of the given, we can see that 50 is playing the role of n here. So this tells us that n is equal to 50. So if n is equal to 50, we can say that 500, which is a sub 50, must be equal to r times 50, or 50r. Solving that, we'll get r is equal to 10. And if r is equal to 10, if we plug that back into the original given information here, we'll get a sub n is equal to 10n. Now that defines our sequence. So this is a sequence for all positive integers n, so it would start with n equals 1. It would go 10, 20, 30, ... And the question we're looking for is how many values of n is a sub n less than 100. Now this is a good example of tactic number 4, where we don't want to solve all the way. Only solve as far as you need to see if the statement will work or not, if it's sufficient or not. So we could definitely finish the sequence out and count how many values of the sequence will be less than 100, but we don't really have to. It's enough to see that it's possible. So we'll stop right there to save time. We'll put a check mark next to number 1 to indicate that that is, in fact, enough. Now, moving on to statement number 2, that tells us that a sub 100 plus a sub 105 is equal to 2050. And we know that here n is equal to 100, so we can replace that, just like we did in the first one, with 100r, plus here n is equal to 105, that would be 105r is equal to 2050. And we saw from the first statement that once we know the value of r, that's going to be enough to say for sure that the statement is sufficient. So here you should be able to look at this equation and say, okay, I know if I solve this out, I'll get a value for r. So that's as far as we need to take this one, and so that means statement 2 is also sufficient. So both statements are sufficient on their own, so that means the answer is D. Each statement is sufficient. The last data sufficiency question we'll look at explores the idea of unwarranted assumptions that was raised in the second hint. So in this one, the question is, what is the perimeter of isosceles triangle ABC with AB equals 10? So we can draw a triangle ABC, and we know that AB is 10. We also know it's isosceles, but we don't know which two sides are going to be the same, so that's really all we can draw so far. If we look at number 1, statement number 1 here, that tells us that BC is equal to 10. So if BC is 10, then it's certainly an isosceles triangle now, and so 10 is AB, 10 is BC, but it doesn't give us any information about side AC. That could still be one of any range of values. So that is not going to be sufficient to tell us what the perimeter is. Statement 2 says that AC is 4. So let's draw this again. If we know that AB is 10 and AC is 4, and again we know that it's isosceles, you might say, okay, well, if it's isosceles, that means BC either has to be 10 or 4, right? So it could be 10, or if you draw it again, it could be 4. So So you might say, okay, the perimeter of this is 18, the perimeter of this is 24, so that's still not enough information. However, we've made an assumption here that both of the triangles are legitimate triangles, and in fact that's not the case. This triangle here is actually an impossible triangle. And that's because there is a rule called the triangle inequality rule that says that any two sides of a triangle added together has to be bigger than the third side, or else it won't really make a triangle. Okay, and to kind of see why that's true, if you're standing at point B and you want to go to point A, the shortest distance between 2 points is just a straight line. So the shortest distance from B to A should be 10, going from B directly to A along this line. Now, if we went from B down to C and then back to A, if this triangle were legitimate, that would mean we only went a distance of 8. But that doesn't really make sense because the shortest distance between the 2 points must be 10, so we can't go a less direct way and only go 8. So this triangle is not valid, so we'll cross that out. So actually, statement 2 is enough to solve the problem, so the answer would be B. Statement 2 is enough on its own, but not statement 1.